Hello and welcome. This is a demonstration of the Thoron procedure in the RadonSniffer app, now available on Android and iOS. We already have one of our radon sniffers running and connected to the app. Let's go into the settings and scroll down until we see the Thoron testing checkbox. We'll enable it. Now when we return to the external detector, you'll see that the Thoron tab has appeared.
Once you click on the Thoron tab, you'll be prompted to start the sequence. After starting, you have 10 seconds to place the inlet tube into the air to be tested.
The first source we'll demonstrate is a radon source inside this container. When I start the sequence, I'll remove this piece of tape, then insert the tube from the RadonSniffer into the case containing a radon source. All right, the filling process has begun. This process will take 90 seconds as the RadonSniffer fills with radon from the container. Now that the RadonSniffer has finished filling, it's best to disconnect the sniffer as it goes through the 5-minute counting phase of the sequence. We do this because in a real-use scenario, the sampling area could have some pressure or suction that would unexpectedly drain or fill the cell, causing incorrect readings. After the 5 minutes have passed, the results will be displayed. Here we can see the readings for radon 220 and radon 222. We're showing nearly 100% radon, essentially 99%, with a reading of 118,000 becquerels per cubic meter. This works out to be about 3,200 picocuries per liter. Now we'll wait another 5 minutes or so to allow it to flush out before starting the next sequence. As you can see on the graph, the RadonSniffer has finished flushing, and we are now ready for the Thoron sequence. Now, we're attaching the Thoron source to the RadonSniffer and starting the sequence by filling the cell. It's important to note that we made a mistake here by attaching the source before starting the sequence. This means it was pulling in the air we want to sample before the sequence starts. Due to the way the sniffer's algorithm works, this has the ability to affect the readings. It is advised to start the sequence before attaching the source, even if this means sampling clean air for the first few seconds of the filling phase of the sequence. The cell is filled, so the 5-minute measurement sequence begins. As expected, we're seeing almost 100% radon 220, 96% to be exact, with about 396 picocuries per liter. There is very little radon 222. When we convert this to becquerels, we see that we are getting around 14,500 becquerels per cubic meter. Now we'll wait for the cell to flush again, before starting our mixed gas demonstration. As you can see by the graph, the cell has been flushed, and we can now start the sequence again. We'll start the sequence, then connect both the Thoron and radon source. The filling phase is done, so we'll remove the source. Another mistake we wanted to note is that because of the similarity to the Thoron source we are using, we accidentally removed the desiccant tube from the device. This tube is designed to minimize any damage to the unit if we accidentally intake some moisture. This should always be connected to the unit. The measuring phase has been completed. We can see we are getting about 16% Thoron and 84% radon. We got 19,500 becquerel per cubic meter of Thoron and 103,500 becquerel per cubic meter of radon. Switching to picocuries, we can see that we have about 530 picocuries per liter of Thoron and about 2,800 picocuries of radon. Thanks for your interest in this tutorial. If you have any further questions or feedback, please leave them in the comments below.